Hi, young chemists. Today we're going to be talking about pH indicators. These are things that indicate whether something is an acid or a base. So I'd like to start with the most simplest pH indicator, and that would be blue and red litmus paper. So here I've got some 3 molar sulfuric acid solution, which is highly acidic. So the blue litmus paper should turn red when I add a drop of the acidic solution to it. So let's see what happens. Boom. There we go, turned red, just like we expected. What happens if we put a drop on the red litmus paper? So red litmus paper is supposed to tell us if something is basic. Since this is not basic, it shouldn't turn blue. There. It just stayed pink like we expected it to. Now how about something that's highly basic? Here we've got ammonium hydroxide, which is just household ammonia, which I bought from Kroger. It's a highly basic solution. So on the blue paper, we should expect to see nothing. But on the red paper, we should expect it to turn blue because it's a basic solution. Boom. And that's what we see. So litmus paper. Probably the simplest form to determine whether a substance is basic or acidic. All right, the next thing I want to show you is universal indicator. So let me turn on my apparatus here. It's got a magnetic spinner inside that spins the solution for me. And here is just water right now. So water has a pH that's neutral. It's around 7. So the pH scale goes from 0 to 14. And water is around neutral, being 7. So this universal indicator, and if you get a closer look at the colors here, this indicator will let you know pHs between 4 and 10. So I'm just going to add some drops in here until we can actually see the pigment. Okay, great. So green, and what's green? It's around neutral. Okay. So what we want to see is what happens when we start adding. Let's go basic first. So let's start adding our alkali solution. Alkali is another word for basic. So as I add the drops, you should start to see it change color. It's going to become more and more blue, and then all the way to purple gradually. Just like it shows on the paper here. Let me get down here so I can see where it's at. Okay, let's add some more. So you see it's starting to turn really kind of a dark blue, almost violet. I think we could say we're pretty basic right now. Very alkali. Okay, now let's take it back the other way. What happens if we start adding our sulfuric acid to the mix? We should start seeing the color change back the other way towards red. So it should go back to blue. Green. Starting to turn yellow now. Just got to let it mix in thoroughly. So there's green. You can see flashes of red when I drop it in there. Oh, now we're starting to turn really yellow. Just be careful here. You can see the red flash when I drop it in there, and then it mixes up. All right, so now we're acidic, all the way to red. So now, what we want to do is take it back to neutral so that we can safely dispose of it. So let's turn this thing back to green. It's a strong acid, so you got to give it a second. All right, still yellow. Let's make it green. Another word for this is neutralizing your acidity. We got to wait till it stables out. All right, looks pretty good to me. Maybe we could go a little bit greener. Let's see. There we go. Now I think our solution is neutral. Okay, so let's take this off. Now I want to show you pH paper. So as you know, different substances have different varying levels of pH. So pH paper is different than litmus paper. It actually runs, I mean, there's different kinds, but this one in particular goes all the way from 1 to 14. So it's a really good pH paper. So first let's do sulfuric acid. And as you see, sulfuric acid is around a 1, so this should turn red when I put this on there. All right, exactly what we expected. Now, here I've got just a few regular household things, like here's coffee, for example. Black coffee tends to have a pH of around 5. So let's see what color we get off of this. Let's let it set in. It's orange. I guess we have to take the pigment of the coffee into account. Okay, here we have just distilled water, so this should be neutral. Here is a solution of baking soda, saturated solution of baking soda. So this should be more alkaline. Now we're going to use my strong base, my ammonia. See what color that gives us. Ooh, a deep purple. So you can see we ran the gamut pretty much of the different colors you could get with the pH paper. Very acidic, slightly acidic, neutral, slightly basic, very basic. Okay, the next thing I'd like to show you is phenolphthalein, which is another indicator. So phenolphthalein, and Here's a bottle right here for you, phenolphthalein. It is flammable. Phenolphthalein turns a pink color in a pH that is between 8.2 and 10. So let me get this spinner started going again. My magnetic stirring rod. And I'm just going to add about 10 drops of phenolphthalein in here. Great. Okay. So as I said, phenolphthalein turns pink in the presence of a alkali or basic solution. So as I drop the ammonia in here, you should see it start to turn pink. It'll be a light pink at first. So let's get this thing stirring faster. Okay. So I don't know if you can see it, but it's already a little bit light pink. So we're just going to keep adding more, and it's just going to keep getting pinker. So this lets you know that we're between 8.2 and 10 right now on our pH scale. You can see it's getting real bright pink. Pretty color. Okay, and just like the other indicator, we can take it back to neutral by adding something that's acidic to it. Now watch carefully how fast, how quickly the pink color dissipates when I drop in the acid. Pretty cool, huh? So now it's back to neutral. Last thing I want to show you. What's also fun with the phenolphthalein solution is that you can draw secret messages with it. So let me get my Q-tip here and I'll dip it in my phenolphthalein solution. And I'm going to turn around and write a secret message I don't want you to see. Okay, now I need to let it dry for a minute, so we're going to give this 2 minutes and then I'll be back to show you the secret message. Okay, I'm back. And the paper's dry now, so I'm going to hang it up here for the great secret message reveal. All right, so as we said, phenolphthalein turns bright pink in a basic solution. What's in glass cleaner is ammonia, which is very basic. So your glass cleaner has a pH between 8.2 and 10. So it should reveal our secret message. Oh, I love science. So in conclusion, there are many different indicators that you can use to determine the pH of your substance. I showed you blue and red litmus paper that basically just shows you whether something is either basic or acidic. You've got pH paper that there's different kinds you can get. This one in particular actually went all the way from 1 to 14, but some packs you can get will just do basic or just do acidic. We did this universal indicator here from Flynn Scientific, which is, I think it's the regular one, which is good for 4 through 10 pH. And of course the phenolphthalein, which is 8.2 through 10 pH, and good for writing secret messages. So thank you for tuning in. Please like and subscribe if you're into it.
To infinity and beyond!